shaka, ooga, 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 shaka, ooga, 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 shaka, ooga, 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 shaka, ooga, ooga. I can't stop this feeling deep inside of me. Girl, you just don't realize what you do to me.
Good morning, good afternoon, good evening, whatever the case may be. We are back and better than ever. And that girl to me is calculus. She does not realize what she does to me. And I am indeed hooked on a feeling. I'm high in believing that calculus is in love with me as well. So we shall fade out the great group Blue Suede, Hooked on a Feeling. Maybe we'll revisit them later. And we shall discuss the calculus, specifically integration by parts. Thank you, Sir Isaac Newton. Thank you. Thank you. Thank you, Gottfried Wilhelm Leibniz. Let's get to it, shall we? Integration by parts. So, consider, boys and girls, these two integrals, the product of two functions. Here we have x e to the negative x, and here we have x cosine x. You would look at that, realize you cannot integrate it straight away, and I imagine you would try u substitution. So let's see what happens. I think we would probably say let u equal either x or negative x. I'm going to go with negative x because it doesn't matter, because we should be able to compensate if u substitution is going to work. The derivative of negative x is negative 1 dx. And you can see if I replace this with the u, I don't have any compensation, and even if I was positive x and it's 1, I would still have the integral of e to the u, because the du is the 1 dx, and it's not going to work out. And what if I had here, let's say, let x equal cosine x? You can see this is not going to work out at all. Dx equal, let u, du equals negative sine x dx, and it's just not, there's no substitution. Just to prove it to you. So we would have the integral of u e to the u du, and we're just right back where we started. So it's not going to work. So how are we going to be able to compensate that? Or how are we going to be able to integrate that if our substitution does not work? Integration by parts is an option, and it comes from the product rule, and it does allow us to integrate a function which is written as a product, as those previous two examples were. So let's start with the product rule. Let's take the derivative of the product of two functions u and v, and that would be, as you know, u prime v plus uv prime. Okay? And if this is true, then I know the integral of u prime v plus uv prime dx is equal to uv. And from there, I would then know that the integral of u prime v dx plus the integral of uv prime dx is equal to uv. And then using just a little bit of algebra, I end up with the integral of uv prime dx is equal to uv minus the integral of u prime v dx. And that is how we integrate by parts. And the key here is that this little puppy right here, we have to be able to integrate it. It's integratable. That is the key. And right now it looks like a big hot mess. But once you get some practice at it, it's really quite nice. You know what to look for, and things work out swimmingly. All right, so here it is and how it appears in the book, and it doesn't appear exactly like this on your formula sheet. This is probably the easiest thing to interpret. I don't know. I've always preferred to use the primes instead of the dv. For me, it just works a little bit better. Okay, so I am going to copy this thing and put it over on the next page for our example. Okay, so we're going to revisit what we had done there before. And, oh, the u didn't come, so I'll just put that in there. And I didn't get the integral of u v prime. Okay, so there's our formula. Okay, so clearly we need u, we need v, we need u prime, and we need v prime. Okay, so here we go. We're going to let, for part A, we're going to let u equal x. So du equals 1. And then here's something a little, or I should say du, or u prime, I should say, u prime. This is a little odd, but we have to integrate u v prime. So we're going to start with v prime, and that is equal to e to the negative x, u v prime. And if v prime is e to the negative x, I have to integrate it to get v, and I get negative e to the negative x. Okay, so now let's use some substitution. So the integral of x e to the negative x dx is equal to uv, so that's going to be x times negative e to the x, or negative x e to the negative x, if I clean it up a little bit, minus the integral of u prime, which is 1, times v. V is u prime v, so that would be negative e to the negative x dx. And I'm going to clean that up a little bit, so this would be negative x e to the negative x, negative negative becomes a positive, the integral of e to the negative x dx. It is integratable, isn't it? I should have pointed that earlier. You can see right away that u prime v is indeed integratable. Okay, and so this is equal to negative x e to the negative x, and the integral of e to the negative x is negative e to the negative x plus c. That is a perfectly good answer, but a more beautiful answer would be to factor out negative e to the negative x, and then we're left with, let's see, x plus 1. Is that correct? Yes, it is, plus c. So if you wanted to check, and I'm going to leave that to you, if you take the derivative of this, guess what? You end up with x e to the negative x. Don't believe it? Try me. Okay. So let's try the second example, x cosine x. So again, our formula for integration by parts is the integral of u v prime dx is equal to uv minus the integral of u prime v dx. Now I'm going to let u equal x. Is it always the first one? Not necessarily. Usually they're nice to you, but if it doesn't work, you can let u be the second function. But you can clearly, you want u prime v to be integratable. So if you let u, if you have an x, or it's to the first power, you're going to get 1. Or if you're even if it has a coefficient, you're just going to get a constant, which is generally going to be integratable as it is multiplied by the second function. So you kind of look for that. Okay, so u equals x. That means u prime equals 1. V prime equals the cosine x. You like the cosine x? Okay, and so I integrate cosine x, and I get v is equal to sine x. Yes? And then we're off and running. So the integral of x cosine x dx is equal to uv, so that is going to be x sine x minus the integral of u prime v, so that's 1 times sine x, or sine x dx. Could this work out any better? So this will be equal to x sine x, and the integral of sine x is negative cosine x, so that becomes, let's see, plus cosine x plus c, and there you have it. Okay? If you want to check, take the derivative, and I guarantee you will get x cosine x. Beautiful. All right, last example. Sometimes life doesn't work out so nicely, and we got to do a little bit more work. This doesn't look too friendly, but upon further inspection, it is a little bit friendly. So again, I'm going to write my handy-dandy formula here, and that is the integral of u v prime. I recommend doing this until you are very familiar with integration by parts, is equal to u v minus the integral of u prime v dx. Okay? So again, I'm going to start off with u equals e to the x. Du would equal, shocker, e to the x. Okay? V prime is equal to sine x, which means v is equal to negative cosine x. And if you're looking ahead and you're saying, yo, Becker, u prime v, that's not any better than what we started with. Well, bear with me on this one, and you're going to see something quite nice and elegant. So now we are going to say that the integral of e to the x sine x dx is equal to uv, so that would be e to the x times negative cosine x, or negative e to the x cosine x, minus the integral of u prime v, so that would be, let's see, e to the x times negative cosine x. In the interest of time, I'm just going to go ahead and right away change that to plus, and we get e to the x cosine x. Okay? Everybody okay? All right. Dx. So now you're like, Baxter, I cannot integrate that. But if we integrate this by parts again, looky what happens. Okay, so I'm going to say, and you're going to, as you get better, you'll be able to foresee this. U equals e to the x. U prime equals e to the x. V prime equals cosine x. Anybody see what's about to happen? V equals sine x. Okay. So we have the integral of e to the x sine x, sine x dx is equal to negative e to the x cos x plus let's see, I got to do uv again, right? So that would be e to the x sine x minus the integral of u prime v, so that would be e to the x sine x dx. And we're right back where we started. But hold the phone, Chuck. I have the same, well, not the same thing. This is negative e to the x sine x, but it's the same integral. And with a little bit of algebra, I can add this to both sides. And on the left-hand side, I get 2 times the integral of e to the x sine x dx is equal to, let's clean this up a little bit and rewrite it as e to the x times sine x. Ooh, that's a horrible sine x minus cosine x. You see what's going to happen here? Yes. And now I divide both sides by 2. Oops. And let's see. So well, I don't really have to put plus c to the end. It's just kind of an annoyance as long as I have it in the final answer. And I really need to isolate this, until I'm done with the integration. So anyway, I divide both sides by 2, and boys and girls, look at this beautiful thing. The integral of e to the x sine x dx is equal to e to the x sine x minus cosine x over 2 plus C. How about them apples? If you take the derivative of this, I guarantee you, you will get this. I know that you are impressed. It is a very cool thing. I don't know why I just did that. I meant to do this. So we can do, why is this not happening? I don't know why it's not happening. I wanted to go out with a bit of hooked on a feeling. Oh, there we go. Let's see how we're doing. That is all I have for you. I hope you are hooked on the feeling of integration by parts. We shall see you next time, and I am out!